Okay, good morning, class. Right. So as usual, okay, please log in this. Please copy this link for a moment. Okay, click this link and enter this code. Okay, for those who use phone, you can just scan the QR code there. Monitor, can you please check who's still not here? Who's still not joining the class? Okay, so maybe for those who just joined the class, okay, so please click this link, okay, and enter the code. Okay, so the code is 48094. Or you just can scan the QR code. If you're using your phone, you can just scan the QR code. Okay, so one more. Okay, so for those who are already here, okay, so we can start our class now. Alright, so I think I stopped last week until here, right? Is it correct? Okay, so now we will answer a few questions, okay? Alright, so can you please answer this one? Okay. Maybe for those who just joined the class, can you please click the link and also put the code and your name? So the question said, which of the following shows the effect of a wave when a water wave is moving from a deep region to shallow region? Okay, so we already learned for reflection. Okay, for reflection, all not change. Okay, means the speed, the frequency, and also the wavelength is same. Okay, except for the direction of the propagation. Okay, the direction will change, right? Okay, how about the refraction? This is A, B, C, and D. Okay, we wait for the answer. Okay, Jayi, Tonzun, Erin, Caroline, Yumin, Jeyu, Sylvan, Zishan, Jayu, Ethan, and Rachel. Okay, Ethan. Okay. All right. So some said C, B. Okay, so mostly answer C. All right. So let's check the answer for this one. So it says the water wave move from deep region to shallow region. Okay, for deep region, the wavelength is much longer than the shallow region. Okay, so let's say this is a deep region. Okay, and then for the shallow region, okay, the wavelength will be shorter. Okay, so here for this one, okay, should be shorter. So this one is wrong. This one also wrong. Okay, how about the speed? So speed V is equals to F lambda, right? So when the wavelength is decreasing, okay, the speed also will decrease. Okay, so the answer should be C. Okay, while the frequency is constant, right? For the refraction, okay, the wavelength, the speed, okay, is depend on the deeper of the water. Okay, how much is the depth of the water? So let's say the depth of the water deep means the wavelength is long. Okay, but if let's say the water is shallow, means the wavelength is much shorter. Okay, so this is the answer. So the answer should be C. Okay, why someone answer B? The speed is not constant. The frequency is constant. Okay, the speed and also the wavelength will change. Okay, it's depend on the depth of the water. Okay, you have to remember that one. Okay, C C C, very good. Okay, D no. Okay, right. So I hope you understand this one. Okay, for the refraction, it depends on the depth of the water. So if the depth of the water is deep, means the wavelength is longer. If the depth of the water is shallow, means the wavelength is shorter. Okay, and the only thing that change for the refraction is speed wavelength. Okay, but the frequency must be constant. Okay, right. So we answer the second question. Okay, what is the formula for refraction? If you want to count the speed or the wavelength, okay, for the deep or shallow region. Okay, so I give you the formula. V1 lambda 1 is equals to V2 lambda 2. Okay, let's check. Okay, Tonzuan, Junhin, Yang Yang, and Jiayu. Okay, right, very good. Okay, so let's check the answer. Okay, so let's say I put V1 lambda 1 is actually for the deep water, while V2 lambda 2 is actually for the shallow water. So V1, it says here the speed of water wave is 5 cm per second in the region of deep water. So this one, the speed is 5 cm s negative 1. Okay, then it asks you to calculate the speed of water in the region in the shallow water. So V1, I put F, okay, and the lambda is 3. Okay, so V2 I need to find, lambda 2 is 1.5. Okay, so 7.5 equals to 3 V2. So V2 is 7.5 divided by 3, so I will get 2.5. So the answer is B, boy. Okay, okay, very good. Okay, very good, Junket. Junket, you show the calculation. Okay, very good, Sean K. 2 or 2.5? This answer is 2.5. Okay, very good. Okay, so we move on to the next question. All right, so it says here the diagram shows the pattern of water approaching a shoreline. Okay, so which of the most suitable location for a child to swim? Okay, so one more. Who is it? Okay. Okay, so let's check the answer. Alright, so it says here which part, alright, which is the most suitable location for a child to swim. So usually for a child to swim, of course, the place should be the water is uh, more calm, right? Right, so the water should be more calm. Okay, so the answer is C. Okay, so the answer is C. Right, so here the depth of the water will decrease. Okay, so the depth of the water will decrease. Okay, and then so means the wavelength should become shorter, right? So it will become shorter. Okay, so then the refraction will occur. All right, and then we already know. Okay, for this one, right? For this one, okay, the shape is like the convex lens, right? Okay, so here means the energy of wave will be spread out. Okay, so the answer is C. Okay, so let's check your answer. Oh, sorry. C. I think we already discussed this one, right? Okay, very good. Right. So the answer should be C. Okay, so let's move on to the next one. Okay, Vicky. Okay, so for this one, this is the shallow part, right? This is the shallow part, and this one is the deeper part. So means here the wavelength is much closer than at this part. Okay, so here should be okay. This one is shorter, and this one is okay more further from each other. So the answer should be A. Okay, because this is the shallow part. Okay, remember the shallow part, the wavelength is much closer to each other, so this one is a deep. Okay, so the answer is A. Okay, correct. Very good. Okay, Junkiat, why you answer C? Okay, let me check what your some of your answer C. C, no. Okay. Shallow usually the wavelength is much closer, right? For the deep part is further from each other. Okay, from the shallow part. Okay, so let's go to the next part here. Okay, remember the deep water, the wavelength is longer than the shallow water. Okay, you have to remember that one. So this one, which one is the deep part? Which one is the shallow part? Okay, three more. See how? Okay, So some answer A, some answer B. Okay, so let's check the answer. Okay, for this one, you can see this is a deep part, right? And this one is the shallow part. So at the deep part, the wavelength should be bigger. Okay, should be higher. It should be further than each other if you compare with the shallow part. Okay, so for this one means the wavelength is bigger. So the answer should be A, right? You can see the wavelength here. Okay, so this is actually the deep part. Okay, and this one is the shallow part. So the answer is A. Okay. For those who answer B, okay, so the answer is wrong because the depth of the water is different. Okay. If you answer like this, means the depth of the water is uniform, means it's same. Okay, there is no deep part or shallow part. Okay, all is same. All is the same level. Okay, so means you can get the B. Okay, the answer is B. Okay, but for C, this one means this is shallow and this is the deep. Okay, all right. So the answer should be A. Okay, Jing, Siobhan. Okay, so if make sure you know that the refraction is actually depend on the depth of the is the refer to the depth of the water. If the depth of the water is deep, means the wavelength is bigger. So if the level water is same, then the wavelength, all the wavelength will be same. Alright. Okay, so don't forget about that one. Okay, how about this one? You can refer the notes. Inside the notes, I already got the answer for this one. Erin, do you have two names here? Oh, okay. So this one, you already answered, right? Oh, okay. All right. So for this one, okay. When it enter the convex, all right, convex shape, okay, of mirror. Sorry, of the perspex. Okay. So this is the convex shape. So the wavelength here should be closer to each other because this one is the shallow area, right? Okay, then you have to know that convex is actually the focus all the wavelength to the one point. Okay, so they will focus to one point here. So this is the F. Okay, then if we go back to the initial wavelength here, okay, like the deep area. Okay, so you go back to like the deep area here for the wavelength. Okay, so the answer should be D donkey. Okay, okay, Junhin, why your answer is C? D, not A, the answer is D. Wait, I check why some of you answer A. Okay, no, because they have to follow the shape of the perspex here. So this perspex plate is in the convex. So they have to follow the convex shape. Okay. And some of you answer C. No, because this one is shallow area. So it's already labeled for you, right? Shallow area. So shallow area means the wavelength will be decreased. Okay. Okay, how about this one? This one is a concave one. Okay, if you convex, they will focus in one point, right? But if concave, what happened? Okay. Alright, so for this one, it says diagram below shows water wave propagating through a perspex block in a ripple tank. Okay, so which wave pattern is observed when the wave pass through the perspex block? Okay, so what will happen here? Okay, so for the convex lens, we already see that all the wavelength will be pointed, okay, into one point. Okay, there will be form a focus point there. Okay, so they will be focused into one point. The point we call it as a focus point. Okay, but how about for the concave lens? Okay, so for the concave lens, right? So it will the wave will be spread out. Okay, it will be spread out. It will be diverged. Okay, so it will be diverged. So the answer should be A. Okay, the answer should be A. Right. So let's check your answer. Wait for a moment. They put the perspex blocks, right? So this one should be shallow. Let me compare the wavelength. Right. Sorry, the answer is B. Okay, the wavelength should be shorter. Okay, the wavelength should be decreased because of the, if you put the perspex below blocks there, okay, they will form the shallow part there. Okay, so the wavelength should be decreased. The answer is B, boy. Okay, mostly answer A, right? Okay, the answer should be B. Because if you put the perspex block, okay, inside the ripple tank, so at the part you put the perspex block, okay, this one, the depth of the water will be shallow. Okay, and this one should be deep area. So you already know when the water travel from the deep to shallow area, of course there will be a change in the depth of the water. So the change of the wavelength. So here the wavelength will become, okay, shorter like that, right? So and then it will be spread out. Okay, it will be diverged. Okay, so it's different from the convex lens. Okay, so the answer is B, boy. Okay, so for this one, you need to type your answer. Okay, so it says here, name the wave phenomenon shown in diagram 2. So what happened to the speed of wave in the shallow water region? Okay, so there are 4 types of wave phenomenon. So the first one, we already learned reflection. Okay, the second one is refraction, the one that we learn now. Okay, and number 3 is diffraction. Okay, and number 4 is interference. Okay, so when they ask you about the wave phenomenon, so this is the answer. Okay, you need to choose either this one. And what happened to the speed of wave? For this one, you have to refer the wavelength. Okay, so what's the difference between the wavelength? Okay, when it at the shallow water of region. So they ask you at the shallow water of region. So usually when they ask you what happened, okay, the answer should be decrease, increase, or no change. Okay, let's check. Okay, so we wait for Jiying, Jisan, and Ethan. So what happened? So Ethan. Okay, Ethan, are you here? Can you submit the answer? Okay. All right, so let's check your answer for this one. So name the wave phenomenon. So this one is actually the refraction of wave. Okay, what happened to the speed of water in the shallow water region? So you can see here at the deep water, the wavelength is higher, right? So V is equals to F lambda. So when the wavelength is higher, of course, the speed also will be higher. So here you can see the wavelength is become shorter, or in which the wavelength is decreased. So when the wavelength is decreased, of course, the speed also will be decreased. So it will move from the higher speed, okay, higher speed to the lower speed. Okay, so the answer should be decrease. Okay, so let's check your answer. Okay, very good. Okay, very good, Junhin. Become slower. All right. No, it's not increasing. You see the wavelength. The wavelength decreasing means the speed also will decrease. Refraction towards a normal. Zishan decrease, not increase. Okay. Okay, how about this one? So what does it mean by wavelength? Okay, usually when I say wavelength, right, I will already say from crest to crest, or from throw to throw, or you can say from, it will form like two semicircles, so then it will form one wavelength. Okay, so how you want to express that in words? Okay, so let's check who still didn't give the answer. Okay, Jisan and Je. Jisan, Je. Okay. Okay, what does it mean by refraction? Okay, so the refraction is the distance, right, between two successive crests or throw. Okay, so wavelength is the distance between two successive crests or throw. Okay, distance between two crests or throw. Okay, so let's check your answer. Wavelength, two adjacent, okay, can accept, okay. Two consecutive point in same phase, correct. Between crests of a wave, okay. Two successive consecutive point, okay. Throw or wave, okay, very good. Okay, this one means for the sound wave, right? Mm, okay. Okay. Most of you got it correct. The length of two semicircle. Uh, this one cannot. Okay. Distance between especially point in the sound wave in okay. Distance between successive to consecutive direction. Wavelength is measured in the direction between two successive points in the wave that captures. Oh, okay. To distance between two crests, okay, can be accepted. Or this one to refraction. This one is for the sound wave, right? Okay, can successive crest to consecutive. Okay. All right. So let's try this one. Okay, you have to compare. So for this one, I let you use the symbol. Okay, you can use the symbol like this. But you have to mention, let's say, I give you one example, okay? Like you compare the wavelength between region A and region B. So wavelength region A is higher than region B. So what you have to do is you put the answer like this. Wavelength, okay, region A is higher than B. Okay, you must put what is the physical quantity here. What did you compare? So you compare the wavelength, you have to put the wavelength, okay, in front of it before you use the symbol. Okay, so let's check who still didn't give answer. Okay, Hansen, Caroline, Yelim, Siobhan. Caroline? Okay. Okay, so for this one, we already discussed. So this one, you have to compare the incident angle theta 1 and refracted angle theta 2. So let's see theta 1 and theta 2. Okay, so theta 1 is much bigger than theta 2, right? The size of it. Okay, so you can say here the incident angle, okay, incident angle theta 1 is higher than theta 2. Okay, the next one you have to compare the depth of water between region A and B. So what you can do here, okay, they already give you a diagram, but they say they didn't give you a diagram. They just give you the wavelength. So what you have to know here, the higher the wavelength, the deeper the deeper the depth of the water. So mean here, this one is deep area and this one is the shallow. Okay, so the depth of water, okay, A is higher than B. Okay, so that's the answer. Okay, so let's check your answer here. Okay. Incident angle is not same because you have to know from the deep water goes to the shallow part. Okay, the refracted ray. Okay, so the refracted angle will be smaller because it will move towards the normal line. Okay, so when you move towards the normal line, the angle of the refracted will be smaller. Okay, from the deep to shallow water, okay, it will move, okay, the line will move, okay, towards the normal line. So when you move towards the normal line, the angle will become smaller. Okay, so this one is wrong. Of course, when the refraction occur, right, of course there will be a change in angle, okay, in angle of refracted. That is the basic part you have to know. Okay, when refraction occur, the angle of refraction and angle of the refracted will become different. It depends whether it move from deep to shallow water or shallow to deep water. It's different from the reflection. Yes, okay, from the reflection, it's not a speed, it's actually we compare the angle, right? For reflection, yes, because the law of reflection said the theta 1 is equals to, the angle of reflection is equals to the angle of reflection. But for the refraction, is different because there must be whether the line move towards the normal line or move away from the normal line. Okay. So relationship, we can use the directly proportional, okay, inversely proportional. Okay. Okay, Jai, Mickey, Caroline, and Sylvan. Okay, Caroline. Okay. Alright, so you have to state the relationship, okay, between the depth of the water and the wavelength, okay. So you can put here the deeper the depth of the water, okay, the higher the wavelength. Or this one you can use directly proportional. Directly proportional. Okay, so both answer is correct. So here you have to complete the sentence below. So when water travel from, so let's say from deep to a shallow region, okay, to a shallow region. Okay, so the direction of the propagation is refracted towards the normal. Okay, this is the answer for those who said that the water travel from deep to shallow. So let's say if you put here shallow, okay, area to deep area. Okay, so what's the answer? The direction of the propagation is refracted away from the normal. Okay, so it depends which part that you use. Maybe you said deep to shallow, so the answer should be towards. If you answer shallow to deep area, so the direction of propagation should be refracted away than the normal. Okay, so let's check your answer. Shallow to deep. Okay, deep to shallow, deep to shallow. Deep to shallow is refracted towards, okay, not away from. Okay, deep shallow towards. Okay, if shallow to deep, then it's refracted away. Refracted. Near. It's not near. It should be towards. Okay. Towards. Okay, very good. Towards. Okay. Not near. It's higher. We're not comparing. It's actually we want to know the relationship. So the relationship we should put the higher, the deeper, the higher. Okay, and another one you can put directly proportional. Okay. The deeper the water, the shorter the wavelength. Are you sure? Not the deeper the water, the higher the wavelength, right? Because at the deep water, okay, the wavelength is much bigger than the shallow part, right? Okay, so the answer is wrong here. Say shallow to deep refracted towards, no, deep to shallow. Okay, this one is from deep to shallow is refracted towards. Okay, Rachel, it's not same. The depth of the water is not same as the wavelength. So another one, the higher the wavelength, okay. Against, not against, is towards. Okay. No, it's not inversely proportional. Shallow to deep refracted away. Okay, very good. Okay, for this one, you need to explain, right? Why most beach resorts are built at the Bay Area compared to the headland. Okay, so 2 marks means you must have 2 points. So this one, this is the Bay Area, right? So usually at the Bay Area, so this is what shape? I give you a clue already. So what happened if they shape like this? What happened to the energy? So how you want to explain this one? Okay, so you just see the shape of the bay. So what is the shape of the bay? And what does the shape do? Okay, for the energy. Okay, for the energy of the wave. Can see the notes. I think the answer is on the notes. Okay, because I already explained, I think. So usually 2 marks means 2 sentence. Okay, but sometimes, okay, they can give 2 marks for 1 sentence. Okay, but it depends. But normally 2 marks means 2 sentence. Okay, so you must have 2 points. Okay, Jayi, Junkat, Puzing, Tonzon, Jiying, Junhee. Okay, jadi I set the U. Okay, the U. I click submit accidentally. Okay. Okay, so let's check your answer. Okay, so it says here, explain why most beach resorts are built at the Bay Area compared to the headland. Okay, so I already draw. Okay, usually at the Bay Area, the shape is like this, right? So this is like the concave. Okay, concave. So concave, you already know. Okay, when we discussed this question just now, okay, it diverge, right? It diverge means it will spread out. Okay, it will spread out the energy wave. Okay, so means when it spread out the energy wave, okay, so into the bigger area, all right, so means the energy will be decreased. So when the energy of the wave decrease, it means that the water will become more calm. Okay, so the water will become more calm. Okay, so here what you can say, okay, so that one is actually for the 4 marks. So what is the only one like 2 marks only? So what you can say here is you just put the energy, right? The energy of the, okay, water wave is spread out to the bigger area, or maybe if you don't want to put energy, you can put the amplitude, because the amplitude is actually represent the energy. Okay, so the water will become more calm. Okay, so that's why they built the beach resort at the Bay Area. Okay, so let's check your answer. Okay, very good, Marian. Very good. It's not convex, it's actually concave. Okay, this one changed to concave. All right. Okay, very good. It's a concave, not convex. Convex is actually at the spread equals the amplitude. Okay. Concave. Concave is like this. Convex because it's like this, right? So it's like that. If put like this, okay. Wait, I draw for you. This one is a convex. Okay. You see this one? Like this one is just like a convex. Usually this is, let's say, the beach, right? So this is the convex part, and this one is a concave part. Okay, this is also a concave, right? Concave. I draw for you just now. It's a concave, not a convex. In focus, okay, disperse, right? Energy will spread out. If you said this one only 1 point, okay, and this one also 1 point, should be 2 sentence. Okay. Okay, very good. Okay, this one only 1 mark. Okay, how about this one? What does it mean by frequency? What does it mean by frequency? Okay, what does it mean by frequency? Okay, so only one more. Who is it? Kai, do we have a presentation today? No. Usually our presentation start from now only on Thursday. So Thursday 1 hour is only for the presentation. Okay. So starting from this week, Tuesday class as usual, and for Thursday, yes, you have to present for 1 hour. Okay, so what is the meaning of the frequency? This is the meaning, the correct meaning is the number of oscillation. The number of complete oscillation, one complete oscillation in 1 second. Number of complete oscillation, no, wait. That one is for number of oscillation, number of complete oscillation in 1 second. That's the answer. Okay, number of complete oscillation in 1 second. Okay, so what's your answer? Wave produce. Number of wave. How can you put number of wave? Right, you can like number of waves. Actually, number of complete, right? Complete oscillation. Okay, this is wrong. Read which current. Why current? This is not electricity. Okay. How recurring event such as wave occur? No, you must put per second. It's actually for 1 second. Okay. Cycles of wave produced. Okay. Number of complete oscillation, number of complete oscillation, the rate per second of vibration. It should be complete. You must have the word complete. Okay. of reference, the rate of current change, vibrating, vibration of constituting a wave. Okay, by particle produced, number of wave of the pass a fixed point in unit time. I don't think I will accept that one. You must have the word complete. Okay, number of cycle wave made. Okay, number of complete oscillation, the number of complete. Okay, so you must have the word complete oscillation. Okay, so let's try this one. So you can refer the depth of the water, you can refer the diagram below here. Okay, I give you 1 more minute to submit the answer. Okay, Mickey, Yvonne, Caroline, Zishan. Okay. Alright, so let's discuss the answer here. So the depth of the water in region X, okay, is deeper. Okay. So you can say here deep depth of the water in region X is deeper than Y. So wavelength of X also is higher than Y. So relate the depth of the water and the wavelength. So this one just like before. Okay, so you can just put directly proportional, or the higher, the deeper the water, okay, the higher the wavelength. So can. Okay, so this is actually the refraction of wave. Okay, so let's check your answer. X is smaller. Why Y is deeper? X is deeper, right? Okay, this one is wrong. The depth of the water is not same. We can compare the wavelength. Okay, so if the wavelength you see there's a difference of wavelength, means there will be different of depth of water there. Inversely proportional, no. It should be directly proportional. Okay, so this is the last one, I think. So you have to explain why the wavefront of sea water will follow the shape of the shore when it approach the shore. Okay, so this is 3 points, mean usually they have 3 points there. Yes, Rachel? So maybe we go for the new topic next week, okay? Diffraction, okay, diffraction of wave. So this is the last question, then I will stop. Okay, make sure you do a revision, okay, because after we finish all the syllabus, right, we still have one more chapter light, okay? I will do the exam, okay, online exam for physics, okay, but this one is only for physics, not for school. This is only for my record, okay? So in case if anything, let's say for your PBD, I have a proof, okay? So make sure you do a revision, okay? So that will be the online test, but the question should be on objective and also the structure, no AC. But I'm not sure, okay? It depends, okay? But no paper 3 and maybe paper 1 and paper 2 only. And the chapter including all the chapter that we have learned, okay? So I will do it after we finish the syllabus. So maybe you can start doing a revision now. Okay, I give you 1 more minute, then we discuss. Okay, Hansen, Kiyin, and Yu. Hansen? Okay, we close the submission. Okay, so let's check your answer. Okay, so here you have to give, right? You have to mention about the depth of the water. Okay, the sea water is decreasing when you approach the beach. Okay, so here you can say the depth of sea water, okay, is decreasing. Okay, okay, and then the next part. Okay, so what will happen to the wavelength? So the wavelength also will decrease. All right, so then the third point is refraction occur. So that's the answer. Okay, good one. Okay, 1 point towards a normal line. Okay, this also can be acceptable. Speed of wavelength. Okay, the water, the speed of wavelength. Okay. This one is actually the answer is in the notes, right? Is it? Because I see some of you give the same sentence. Words. No. No. Teacher, can show teacher answer again? Yes, after I finish marking, I will show you the answer. Or I can put this one in the group. Okay. I will save as PDF, then you can just copy the answer from there. Mm. Mm. No. Okay. Deep to shallow. Okay, I prefer for you to answer in this kind. Okay, in the point form. Okay, so it's easy for me to see the point there. No. 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 Okay, correct. Okay. All right. So I think I stop until now. So on Tuesday, prepare okay for the presentation. Okay, and then next week we continue for the reflection. Okay. So thank you, class. Okay. So take care, everyone. Okay. Stay safe. Bye. Okay, welcome.